very satisfying as an engineer to hear about programming and hear his gospel preaching. Okay, so we're gonna look at pretty graphs now. Pretty graphs. Yeah, I love pretty graphs. So my name is Ben. I started working at Sentience recently. My background is in machine learning. I was mostly working in voice and phonetic analysis stuff. And I hold a degree in linguistics, so a lot of the problems that I focus on in the machine learning world are hyper specific to linguistic problems that require a lot of nuance. So what we see up here is a PCA graph 3D of my life for the past year, basically. So a lot of text, a lot of Slack, a lot of email threads, and also I threw my thesis in there chunks to give some academic diversity. So what we're looking at basically are different registers in my writing, and it's also representing both the document store that is my sentience as well. So what we're going to talk about today is that one person is many voices, and that's why tone and style is a hard thing to model, and can't be modeled just via a markdown file, or telling Claude really hard to stop using M-dashes, because that doesn't work. So let's get into it. Basically, everything to date, benchmark-wise, when you go on plugging safety valves or something like that, is converging around basically an oversaturated data set of PhD writing, academic writing, right? Like this is optimizing for very specific Q&A tasks, right? Where I think if people remember the early days of BERT models, the Q&A tasks and classification tasks were all basically oriented around small Google developed data sets that work for question and answer from Wikipedia or something like that. So the actual text, the writing task, if we're going to talk about modeling human writing, all of it's optimized for this global minimum of just question answer, right? Which is not really something we care about. We care about, I'll speak a little bit about this slide, I guess, before I go on, but we could call these two things grammaticality and truthiness, right? Grammaticality, it sounds like English, it is English. Truthiness, it sounds like Wikipedia or a PhD wrote it. Good, yes, seems true, cool, it's coherent and intelligible. That's what we're optimizing for. But actually, all of the stuff that has been pre-trained, lives over here in the highly informational axis of things. And I adopted this approach that Viper, who's a corpus linguist back in the 80s, kind of proposed, which is this axis of informational versus involvement, right? So it's sometimes there's different registers of speech, and we're interested sometimes in this talk about delivering information. Other times it's more about involvement. It's about writing a text to a loved one. It's about the emotional context that's there, or the pragmatic context of what I'm speaking to and my relationship to them. Most of the tasks that we care about agents helping us with live over here, even though most of the stuff that is in pre-training lives over here. Right, so that's kind of the fundamental problem, and what I'm proposing today is basically that everything that we've been training towards and optimizing for, doesn't really take into account preference, and doesn't really take into account tone style, and I said, intent and judgment, which is a little bit more nuanced, but are subjective problems that have to do with values, preferences, how I make decisions. The fact that I'm an engineer means that I make decisions in a certain way, different than other people. Okay. So we can move on now. But yeah, you can imagine that all of this means that, tone and style personalization is not a pre-training problem. It's a post-training problem. So this is kind of where we get into the question of fine-tuning, Q-LoRa adapters, all of that. But, you can't really pre-train a voice, and moreover, P is much, much greater than it. If we already accept that, the models that we've trained to date require billions of parameters to even, get close to modeling basic speech acts, think about every context, every possible interaction I had when over the course of my life. Those are other dimensions that we haven't even begun to measure, and they certainly exceed our ability to pre-train for. So it's much more likely that it's a post-training problem. So this is kind of working through my methodology as I started trying to tackle this problem. So yeah, here is a fun graph. Basically, one of these is the semantic embeddings, which are just taken from Gemini. Really basic. And the other side is a style index. So a model is actually pre-trained to do embeddings based off of where that text came from, what the context of it was. So the channel is what we kind of call it at Sentience, right? Channel being Slack or email or iMessages or something like that. And you can see that the clustering is very different. Kind of the most interesting thing is that while they both manage to identify distinctive clusters, the actual ability to create tight clusters along the axes that we care about is outperformed by a much smaller, more rough embedding spot. Like these are 768 dimensional embeddings versus Gemini's highly optimized 2022 ones. And yet we get much better performance in terms of retrieval if our goal is to retrieve something which is stylistically similar to something in the corpus, and we use a smaller model that's been optimized for style as opposed to semantics. So again, this is sort of pointing out that like the field of retrieval has not really been targeting this idea of personalization and tone of style. That we really just been after retrieving semantic information, which is way more of the layer that Anna is talking about. Okay, so this is a fun one. I love this. So here's Ben, and here's me, and Sam and Abba. So semantically, we're all jumbled up because we work together and we do similar things for similar ages, we have similar lives, and we're all jumbled up semantically. This is our real data, by the way. And then stylistically, you can actually see clusters. Like, I mean, obviously, this is dimensionally reduced, so you can't trust the images as much. But like, still, like, it's pretty amazing that with like a much smaller embeddings model that I just ran locally on my computer versus Gemini, I'm able to actually see like distinctive voices emerge. And we also see this like axis, right, of formality, right? I would speculate that what we're seeing here of these two large clusters really has to do with formality. And yeah, just again, like using this approach in-house allows us to retrieve a much like closer neighbor of what we actually want to emulate, like in terms of tone and style exemplars, which is kind of how I'm thinking these things. Like say I want to write a certain type of email, how do I retrieve a previous email that's really close to that as an exemplar? This allows us to do that and also recognize distinct voices from like my voice versus Teddy's voice versus Sentience. And this is just an interesting little extra graph like the Fable make that is just kind of showing that the corpus linguistics backs it up, which is that each of these channels have like very different sort of, if we were just to take a classic NLP approach and look at, words like exclamation marks and M dashes per thousand words, like you see that these patterns emerging and reinforced. And then yeah, I'll just end here, which is the whole map explorable. And you can even mouse over them if you want to get like really all up on my data. But yeah, so yeah, you can kind of see the axis here, right? Going back and forth. But yeah, that's all I really wanted to talk about. I also have like a references thing. I'll hopefully put out like sort of backing research for this. But yeah, any questions?